Okay, so you've definitely heard the word blockchain thrown around everywhere, right? Usually right next to Bitcoin. People say it's going to change, well, everything. But what is it, really? Let's cut through the hype. In the next few minutes, we're going to break this whole thing down and figure out why it actually matters.
But first, think about this for a second. We live in a world where you can send a message to the other side of the planet instantly. So why does sending money or signing a really important contract still feel like it's stuck in the dark ages? We have to rely on these middlemen, banks, lawyers, you name it, to be the referees. This basic need for a trusted go-between is the exact problem that blockchain was created to solve.
So to really get what blockchain is all about, we first have to talk about the problems it was built to fix. And it all comes down to one simple but huge issue that we deal with every single day: trust.
I mean, look at our current systems. They all rely on these central gatekeepers, like a bank, right? And that creates all sorts of bottlenecks. Transactions can be painfully slow, digital records can be secretly altered or just plain faked, and a lot of the time, information is just hidden away where you can't see it. What it really boils down to is this. We've built this amazing digital world on top of a really old, kind of clunky analog model of trust.
So the big question is, how do we build trust directly into our digital world? Well, that's exactly where blockchain comes into the picture. And believe me, the best way to understand it isn't with a bunch of complicated code, but with a really simple analogy. At its absolute core, this is what a blockchain is. It's a new kind of database. Think of it as a new way to write things down, a way that's secure, transparent, and almost impossible to change later. But what does that actually look like in practice? I want you to imagine a very special kind of digital notebook. Every page in this notebook is what we call a block, and you fill it up with information, like transactions. Once a page is full, you add a new one, but, and this is key, you link it securely to the page before it. This creates that chain of blocks. And here's the magic part. This notebook isn't owned by just one person. A copy is given to everyone in the network. Okay, so we've got this shared digital notebook. Pretty cool. But what makes it so secure? I mean, what stops someone from just going back and changing something on a previous page? Let's look under the hood, because this is where the real genius of the technology starts to shine through. So let's zoom in on a single block, a single page in our notebook. Each one has three key ingredients. You've got the data itself, you've got a unique digital fingerprint called a hash, and this is the most important part. It also contains the hash of the block that came right before it. That connection, that's the glue that creates the chain. And this is the secret to its security. If you try to go back and alter any data in a block, even change a single comma, its digital fingerprint, that hash, completely changes. And because the next block in the chain is looking for the original hash, the link breaks. It's like a digital tripwire. If you mess with one link, the entire system immediately knows something's wrong. But you might be thinking, okay, what if a hacker changes a block and recalculates all the hashes for the blocks that come after it? Great question. That's where the shared notebook idea comes back in. The entire blockchain is copied and distributed across thousands of computers, which we call nodes. So for any change to be accepted, the vast majority of these computers all have to agree. Hacking one computer is useless, because its copy of the notebook would no longer match everybody else's.
So how does this huge network of computers actually agree on what's true? They use systems called consensus mechanisms. The two big ones you'll hear about are proof of work, which is what Bitcoin uses. It's like a race where computers compete to solve a really complex math puzzle to add the next block. It's super secure, but as you've probably heard, it uses a ton of energy. The other popular one is proof of stake. This is more like a lottery, where users who stake or lock up their own currency get a chance to be chosen to validate transactions. It's a much more energy-efficient way to get the same job done.
Okay, enough of the technical stuff. We've covered the what and the how, but what about the so what? Why does any of this matter? Let's take a look at how this technology is actually being used out in the real world, way beyond just cryptocurrencies.
Seriously, the potential uses are huge. In supply chains, you could track an apple from the orchard all the way to your grocery store, proving it's organic and fresh. In healthcare, you could control exactly who gets to see your medical records. People are even building tamper-proof voting systems and using it to speed up the complicated process of buying a house.
Now, the engine that powers a lot of these innovations is something called a smart contract. The easiest way to think of it is like a super smart vending machine. The contract has a simple rule coded into it. If a certain thing happens, then automatically do something else. For example, if the shipping company confirms the package was delivered, then automatically release the payment to the seller.
No lawyers, no escrow, just automated trust.
So, this technology sounds pretty revolutionary, doesn't it? And in many ways, it is. But it is not a magic bullet. To get the complete picture, we really need to look at both sides of the coin, the incredible benefits and the very real challenges that come with it.
On the one hand, you get this amazing security, transparency, and efficiency that can cut out middlemen and lower costs. But on the flip side, let's be honest, this stuff is still pretty complicated for beginners. Some blockchains, like we said, use a staggering amount of energy, and governments all over the world are still trying to figure out what the rules should be. It's an incredibly powerful tool, but it also comes with a brand new set of challenges.
But despite those risks, the future is looking incredibly exciting. We're seeing the explosion of decentralized finance, or DeFi, which wants to build an entire financial system without any banks. You've heard of NFTs, which are changing how we prove ownership of digital things. And we're just scratching the surface of how blockchain can work with AI and the Internet of Things to make our world smarter and more secure.
So, when you strip it all down, what's left? It's a new model of trust, one that's shared, transparent, and automatic. Blockchain offers us a potential world with less friction, fewer gatekeepers, and more direct control. The real question isn't just about the technology anymore. It's whether we as a society are ready for what that world actually looks like. I'll leave you with that to think about. Thanks for tuning in.